In this video we're going to look at factorising harder quadratics, that is where the coefficient of x squared is greater than 1. But before we go on to the method, I'd like to look at an actual example of multiplying brackets together, because there are three particular properties which are worth noting. So we'll start with the example 2x plus 3 multiplied by 5x plus 7. And after expanding these brackets, we find the answer 10x squared plus 29x plus 21. Now the first property, property A I'll call it, is the product sum product formula. Product sum product. And what this states is that the product of the sum of the coefficients in the factors is equal to the sum of the coefficients in the product. So the product of the sum of the coefficient of the factor, these are the two factors, and the sum of the coefficients here is 2 plus 3 is 5, and 5 add 7 is 12. The product of these two is 60. So that's the product of the sum of the coefficients in the factors, and the sum of the coefficients in the product is 10 add 29 add 21 is also equal to 60. And that's property A, and it's worth remembering, and also can be used to check any product, any algebraic product. Property B is to do with splitting the middle term. So if we take, it's a ratio or proportion. So if we take the middle coefficient 29, it can be split into two parts, a 15 and a 14 in this case, so that the first coefficient, 10, is to this first part, 15, as 14 is to 21. And that can be used to help factorise some of these harder quadratics. The third property, property C, is that the worth mentioning here is that the product of the first term and the last term, in this case 10 times 21 is 210, is equal to the product of the middle two terms. 15 times 14 is also 221. That in fact is true for any ratio equation. So for example, if we have 2 is to 3 as 4 is to 6, we can easily see that 3 times 4 is the same as 2 times 6. And again, this can also help in finding these two missing numbers in the proportion. Now moving on to the general case, if we take two binomial factors, say ax plus b, and multiplied by cx plus d, the result will be acx squared plus ad plus bc times x plus bd. So that's the general form. And if we lay these coefficients, these four coefficients a, b, c and d, out into a matrix like so, it's just a matrix in shape. There are various things to note about it. First of all, the vertical product of A and C is the coefficient of x squared. So that gives us ACx squared. Secondly, that the vertical product of these two numbers, b and d, gives the independent term bd. And thirdly, the sum of the cross product, AD plus BC, gives the coefficient of x. And using these three things, we can get quite a simple way of factorising harder quadratics. So I'm going to show now 6 examples of where this matrix form, using the vertically and crosswise pattern, can be of great use. We'll start with 5x squared plus 36x plus 7. Now the key to this process is to look at the primality of the first and last coefficients. In this case, both are prime. So in our matrix, we must be dealing with a 5 and a 1, because 5 times 1 is 5. And the last two numbers here must be a 7 and a 1. And then we consider the cross product. The only way we're going to get 36 is with a 7 here and a 1 here. So 5 7's 35, plus 1 1 is 36. And from that we can immediately write down the factored form as 5x add 1 times 1x plus 7. Example 2 is 8x squared plus 14x plus 3. Again, looking at the first and last coefficients, we can see that the last one is prime, and so in the matrix we must have a 3 and a 1. Now we've got a choice in with 8, because it's got two pairs of factors, 1 and 8 and 2 and 4, and we have to consider which of those is going to lead us to a cross product which adds up to 14. Well, the only possible numbers will be a 4 here and a 2 here, because 3 4s are 12 and 2 1s are 2. And that immediately leads us to 2x plus 3 times 4x plus 1. Example 3, 5x squared minus 17x plus 6. Here again we see that 5 is prime, so we'll start with a 5 and a 1. And 6 we have two pairs of factors, 1 and 6 and 2 and 3. Note here that we've got a negative 17 here and a plus 6. So both of these numbers are going to have to be negative. And it won't take much to see that we'll need 3 5s and a 2 here. So we need a 3 and a 2, and they're both negative. This gives minus 15 take away 2 is the minus 17. And the result is 5x minus 2 times x minus 3. Example 4. We have two negatives in this one, 3x squared minus 11x take away 4. And again we can start with the prime coefficient here, a 3 and a 1. And again we've got two choices of factors here, but because there's a negative sign here, one must be positive and one must be negative. So if we try 2 and a 2, this won't work at all, because we're never going to reach minus 11. So it must be a 4, which will go here, and a 1 here. And then we can start sorting out the signs. 3 times minus 4 is minus 12, plus 1, and the result is 3x plus 1 times x minus 4. The next example, example 5, slightly harder. is 6x squared plus 17x plus 12. Now this is harder because 6 has 2 pairs of factors and 12 has 3. It's got 1 and 12, 2 and 6 and 3 and 4. And this is where the proportion method of splitting the middle term comes into use. And we can write down the ratio equation 6 is to something as something is to 12. And the two somethings have got to add up to 17. Well, after a little thought about this, it should be easy to see that we can have a 9 here and an 8 here. These two numbers can be placed around the other way as well. And the process then is to reduce either of these ratios to lowest terms. So that's 2 is to 3. And that gives the first row of the matrix 2, 3. And from that we can easily see that 2 times 3 will give the 6, and 3 times 4 will give the 12, and we have 2x plus 3 times 3x plus 4. Example, that's 6. 9x squared minus 3x minus 20. So this is getting a little bit harder, and this time we need to split the middle term. It's only minus 3 here, but it's 9 is to something as something is to minus 20. And we need to find that these two somethings add up to minus 3. So one is going to be positive and one negative. And we can make use of the property mentioned earlier, which is that the two missing numbers here have a product of 9 times minus 20, and that's minus 180. So we need to find two numbers that not only add up to minus 3, but which multiply to make minus 180. And the answer is 12 and negative 15. So we'll put a 12 here and a negative 15 here. Reduce either of these fractions to lowest terms, 3 to 4, and that gives the first row of the matrix. 3 times 3 is 9, and 4 times minus 5 is the minus 20. And so the factorized form is 3x add 4 times 3x take away 5. Well, I quite like this matrix method. The cross product is fairly easy to find. Not only that, we can use the matrix to solve quadratic equations. So for example, in example 5, if we had 6x squared plus 7x plus 12 equals 0, once we've got the matrix, all we need to do to find the two values of x which satisfy this equation are to take these two numbers, one over the other, and change the sign, giving it minus 3 over 2. And for the other answer, it will be x is equal to minus 4 over 3. And in this last example here, if we have this is equal to 0, then from the matrix we can arrive at the two answers. X is minus 4 over 3, or x is 5 over 3. We put one number over the other and change the sign, and that's it. Well, I hope you find that matrix method is nice and easy and will help you to factorize and solve these harder quadratic equations.